Okay, so hi. um, Today I'm going to be doing my video on myoclonic epilepsy with ragged red fibers. That's the disease that I'm doing. Okay, so basically what it is, myoclonic epilepsy with ragged red fibers, or stands for MERRF, or as I like to say, MERF. It's a mitochondrial DNA mutation in the RNAlysis gene. It's a disorder that affects it affects many parts of the body, particularly the muscles and nervous system. And the mitochondria deals with like energy and things like that, which is why like when it affects your muscles, it makes it hard to do like kind of physical things like that. So that's a part of it. Some of the phenotypic features, kind of like symptoms, almost kind of. They usually show during like childhood or adolescence, and they can like if everyone in your family has the mutation, like the symptoms can vary, like even if you're in the same family. And some of the symptoms are cardiac arrhythmia, which means kind of like improper beating of the heart, so kind of like heart palpitations, and then hearing loss, chronic headaches, optic atrophy, dementia, and a big one is seizures. Um, Usually, like when doctors diagnose this to people, they'll use like these symptoms, but they'll also use like a muscle biopsy, and that's where the ragged red fibers come in. So if they see those, that'll usually be a sign that this person um, has this disease. One of a case study was done. It was a 29-year-old. She was like perfectly healthy um, at first, 29-year-old, and then she started beginning to complain about kind of daily jerking of some of her limbs, almost like tics. Like when people have tics, it was kind of like that. She began to have trouble exercising, and she started experiencing um, chronic headaches. And so the one time she was actually admitted to the hospital was after she experienced a seizure. But before that, like it was just kind of like basic symptoms that no one really thought anything of. And the only family history that she had reported was an uncle with multiple sclerosis, but that didn't really have anything to do with it. So once she started having more symptoms, um, she was finally readmitted back into the hospital after her symptoms worsened and she started having more seizures and she became more dependent. So she, was used to living by herself, doing things on her own, but she slowly needed help doing more things. So there's an MRI done on her brain and it revealed diffuse cortical atrophy with prominent CSF spaces for her age. So there was like more spaces in her brain than should have been for a healthy 29-year-old. And they also did a muscle biopsy, which showed appearances consistent with myoclonic epilepsy with ragged red fibers. So the muscle biopsy was really what showed them that she had this um, type of uh, disease. And so yeah, that's kind of what happened. There's not a lot of there's no like cure or anything. So like they just kind of gave her medicine for things like her headaches and things like that, but there's not like a cure yet. So yeah. Okay. Uh, Etiology and pathogenesis. So during fertilization, the zygote receives mitochondria only from a oocyte. Um, mDNA is transmitted from mother to all male and female offspring. So basically, this mutation can only come from the mom, but we'll talk about that later, like when it gets to like inheritance and stuff like that. Most common mutation is usually an A to G mutation. Mutations in the mDNA disrupt MRC, which results in decreased cellular energy. So like in the case study when she was saying that she was having a hard time like exercising and things like that, it's because this type of mutation affects your mitochondria with which helps with energy and things like that to the body, which is why like physical activities can become kind of difficult, and that's like one of the first kind of signs of it, or it can be. And then mutations within these specific genes reduce the ability of the mitochondria to maintain its normal function, which help the body stay energized and affect physical activity, which is what I just said. But yeah. Management, like I said, there's no cure for MERRF. I like to call it that. There's no cure for it, but they just use different medications for like the different symptoms that you have. So, like physical therapy, standard medication for cardiac symptoms, like migraines or headaches and things like that. They just kind of use those to kind of lessen the symptoms, but there is no cure for it. Um, inheritance risk. MERRF has a mitochondrial or maternal inheritance. Mitochondrial inheritance only comes maternally since it's inherited through egg cells. So this type of mutation can only come um, from your mom. So like usually what happens, like it says, if a mother has mutations, the children will inherit it. And so basically the way it works is like, say a mom has 3 kids, all 3 kids will have the mutation because they'll have it from her. But they may not show symptoms. And like if the mom doesn't show symptoms, like the kids may not show symptoms. But the only people that can pass it down to their kids are if she has a girl. So if she has like 2 boys and a girl, that girl will pass the gene down to her children and her children, so on. But the boys can't pass it because it doesn't come from sperm cells. The mutation won't pass through sperm cells, so men technically cannot pass down the mutation. So that kind of sucks for us girls, because we just keep um, giving it to like our just kind of keep giving it because it's only a maternal trait, and men can't give it to like their offspring or anything like that. But like it says, if a mother has mutations, the children will inherit, but some may not show symptoms, some might. It just kind of depends. So, and these are my citations. I really enjoyed learning about this type of disease. I didn't know it existed like at all. Um, and it's definitely cool. Not cool, but it's interesting to see that kind of like the symptoms can start off as like everyday things like a migraine or having trouble with exercising, but they can like slowly get worse and worse and worse, as we saw in the case study, because it started off as like a regular migraine and like just having trouble exercising, and it ended up becoming a lot worse than that. I think the most interesting thing that I learned was the maternal inheritance, that it only comes from mothers. So like mothers and women can only pass this trait down, men can't because it doesn't pass through sperm cells. Um, so I thought that was pretty interesting. Also, another interesting thing that happened in the case study was that at first they ran a ton of tests, and they ran like tests over her blood and things like that, and like everything looked normal. And it wasn't until she was readmitted into the hospital and that they did the muscle biopsy that they actually started to see like signs that led to myoclonic epilepsy. And that was when they really were like, oh, okay, something's a problem. So I think it's also kind of like uneasy to know that it like cannot it can take a while to be caught, and it may not be caught right away. So yeah, that was the disease that I did my research on, and I hope you enjoyed this. Thank you. Alrighty.